Okay, so right now we are going to continue with our lessons, with our learning. We are now at the 7th lesson, which is outer joins. Okay, so depending on how you want to analyze the data, the inner join we used last lesson might not be sufficient because the resulting table only contains data that belongs in both of the tables. Okay, if the two tables have asymmetric data, okay, which can easily happen when data is entered in different stages, have to use left join, right join, or full join instead to ensure that the data you need is not left out of the results. Alright, what does that mean? Inner, left, right, full join. My table ID, another table, matching ID. Okay, like the inner join, these three new joins have to specify which column to join the data on. When joining the table A to the table B, left join includes row from A regardless of whether a matching row is found in B. Okay, what does that mean? Right join but reverse, keeping rows in B regardless of whether a match is found in A. What does that mean? Okay, full join simply means that rows from both tables are kept regardless of whether a matching row exists in the other table. Oh, includes row. Oh, I see. So, okay, the previous one, inner join, we combine the two tables and then we delete the matching tables, right? But this one, I guess it will just join the tables, and if there is a matching, it doesn't matter if there is a matching row regardless of whether a matching row is found. Matching row or matching column? Wait a minute. Let's just look at the exercise later. When using any of these new joins, you will likely to have to write additional logic with nulls in the resulting constraint. What? Okay. That's okay. You might see queries with these joins written as left outer join, right outer join, full outer join. Outer keyword is really kept. For SQL 92 compatibility, the queries are simply equivalent. Alright. Exercise. In this exercise, you are going to be working with a new table which stores fictional data about employees in their film studio and their assigned office buildings. Some of the buildings are new, so they don't have any employees in them yet. But we need to find some information about them regardless. Okay. Since our browser SQL database is somewhat limited, only the left join is supported in the exercise below. Alright. So we are going to use the left join. Okay, so we have two tables right here, buildings and employees. So what are we going to do? Find the list of all buildings that have employees. Okay, this is the buildings, 1E, 1W, okay, capacity. Then we have this building. So I guess building will be matched with this, right? Find the list of all buildings that have employees. Okay, wait a minute. How do we do that? So, wait. If we want to join them, right? Left join. Simply includes rows from A regardless of whether a matching row is found in B. Have to specify which column to join the data. Okay, so we need to have the same, like the ID. In this case, the building name, right? And then whether a matching row is found in B. Includes rows from A. So I guess everything that is joined, like this one E, they will have another column, for capacity, and 24, 24, 24, 24. I think it's like that. That's my guess. That is my guess. So let's try joining them first. Select all from my table, and then left join another table. Okay. Left join what? Buildings. Yeah. Oh wait, what? 1E, 1W, 2E, 2W. What is this? Why is it like this? This is weird. Find the list of all buildings that have employees. Join on what? Building name with building name with building name. No such column buildings. Yeah, building. Yeah, this is what I suspect. It's gonna be like this. So find the list of all buildings that have employees. So just print out this, right? Just print out the building name. Select. Okay. So where is not is wait. Find the list of all buildings. Find the list of all buildings. Like from inspection, we can answer 1E, 2W. But how do we get 1E and 2W? How do we get 1E and 2W? I think we just make it this thing, right? Select this thing, building. Alright. Find the list of all buildings and their capacity. Listing building, and then capacity. Find the list of all buildings and then all. So okay, we join them. So now we don't have what 1W and 2W, right? And 1W and 2E. So oh man, I don't think we need to join them because this is already the list of all buildings and their capacity. But what we are learning in this lesson is joining. So how do we do that? Listing building capacity from employees. From what if we do from buildings, left join with employees, and then we just reverse this thing. Wow. Okay, what if we don't join them? Listing building capacity from buildings. No such column building name. Oh, okay, I guess that is doable. We can do that. List all buildings and the distinct employee roles in each building. Wait, okay, I'm a little confused right now. Okay, list all buildings and the distinct employee. List all buildings and the distinct employee in each building, including empty buildings. Including empty buildings, so we need to take the buildings, buildings table first, right? And then we join, and then we join it with the employees table on, building name equals building oh, okay, building name equals building. Oh no, distinct. Distinct what? Building and the distinct employee roles. Employee role. Building name. Then the roles. Role. Yeah, nice. Okay, next. Lesson 8. A short note on nulls. As promised in the last lesson, we are going to quickly talk about null values in an SQL database. It's always good to reduce possibility of null values because they require special attention. Okay, when processing, an alternative to null is to have data type appropriate default values like 0 or empty string. But if your database needs to store incomplete data, then null can be appropriate. Okay. Averages. Okay. Sometimes it's also not possible to avoid null values, as we saw in the last lesson. Okay, in this case you can test a column for null values in a where clause using either is null or is not null. Okay, just checking the condition, right? Yeah, that's why we use where. Where is for the condition. Okay, let's go. Exercise. This exercise will be a sort of review of the last few lessons. We are using the same employee and buildings, but we have hired a few more people. Okay, but they are not assigned building yet. That's fine. Find the name and role of all employees who have not been assigned to a building. Select, hey, I don't think we need to join anything, right? I don't think we need to join anything. We just select from employees where the building is null. Building is null. Settled. Find the names of the buildings that hold no employees. That one, we go to the okay, wait. Find the names of the buildings. I think select buildings, right? Select building from employees. Select building from employees. Such that what? Building from employees. Okay, maybe we need to join. Then use the building name. Right? Yeah, I think we need to join. Select building name from buildings. And then, okay, wait for the condition. Okay, we have building names. Okay, and then we want to join them. Left join them. Left join with the employees table. Okay, why? That's what happened. Okay, this thing. Okay, this thing. Okay, let's join employees, and then Okay. Let's say for all, what will happen? Building 1W, 2E, 2W. Okay, this is not the right. Oh wait. On. I forget to put on. Building name equals building. Yeah. Is this the right way to do it? I think so. So now we just whine where the role or the name is empty. Where name is none. Settled. Nice. So next is lesson 9, queries with expression. In addition to querying and referencing raw column data with SQL, you can also use expression to write more complex logic on column values in a query. These expressions can use mathematical and string functions along with basic arithmetic to transform values when the query is executed, as shown in this physics example. Okay, what is this? Particle speed. Oh no, this is physics. Divide by 2, half particle speed. Okay. Physics data, absolute. I think this is absolute. Absolute of the particle position times 10 bigger than 500. This is the condition. Again, we are checking for the condition, right? Each database has its own supported set of mathematical string that can be used in a query, which you can find in their own respective docs. Okay. The use of expression can save time and extra post-processing of the result data. But it can also make the query harder to read. So we recommend use in the select part of the query. Or what? That they are also given a descriptive alias using the as keyword. Select call expression as expression description. What is this? Column expression description. So this is like a variable or what? Select particle speed as half particle speed. Before this, we use select to choose a column, right? But this time, what are we doing? The select, the expression are used in the select part. Okay, honestly, I don't understand. This is the expression. So if the expression is used in the select, we put as in we name it. Okay, I think that's what what they are trying to tell us, I guess. In addition to expression, regular columns and event tables can also have aliases to make them easy to reference in the output and as a part of simplifying more complex queries. Okay, along widgets table name as my widgets. So then we can use my widget. Yeah, I think this is just variable, right? Naming a variable. That's a good way to shorten things. You are going to have to use expression to transform the box office data into something easier to understand from the task below. Okay, so we have movies and the box office again. List all movies and their combined sales in millions of dollars. Oh, I see. Movies and their combined sales. So we need to add domestic and international, and then because it's in millions of dollars, we need to divide by 1 million. Yeah, that's the plan. So we need to join first. We need to join them first. Okay, wait. Join or inner join. inner join, wait, ID, inner join, box office, on ID equals movie ID. Okay, now we have this. Okay, so now we want to select white. Column expression. Okay, select combine sales as, oh wait, no, that's not how we do it. Domestic sales plus international sales as combined sales. That's how we do it. And also the title, incomplete SQL query. What is the column title? Okay. Right, now we can't even access the title anymore. Why can't we access the title right now? Select from movies, inner join box office on ID equals movie ID. Okay, how do we, I don't know there. Okay, I don't know how we are doing this. What I know is that we need to have the title of the movies too. So how are we doing that? How are we doing that? Okay, what I understand is that S is for the variable naming a variable, changing the names. So right now, why can't I? Why is this a incomplete SQL query? Why? Why is this an incomplete SQL query? Is it because of the space? No way. Oh, okay. Millions of dollars. Divide by 1, 3, 4, 5, 6. Wait. Okay, we need to have parentheses. Set it. Combine sales. Oh, we cannot do that, fortunately. That's fine. List all movies and their ratings in percent. In percent times 10. I guess times 10. Okay. List all movies and their ratings. Title and then this one. change it as y. Rating times n. Alright. List all movies that were released on even number years. I don't think we need to join anything, but let's just leave the joining. List all movies that were released on even number years. Okay, so from movies, okay, where why don't we put here where y. Wait, okay, where year. Okay, where, this is logical, right? Where year divided by 2 is not equals to does modulo work? Not equals to 0. I don't think it works. Oh, even. I see. I did a mistake. Okay, my mistake. My fault. Okay, next. Lesson 10. Queries with aggregates. We are at lesson 10 now. We are kinda quick. Start at 7. In addition to the simple expressions that we introduced last lesson, SQL also supports the use of aggregate expression or functions, allow you to summarize information about a group of rows or of data. Pixar database aggregate functions can be used to answer questions like how many movies has Pixar produced, highest grossing Pixar film each year. Aggregate function, column or expression as the name. We need to have an example. Without a specified grouping, each aggregate function is going to run on the whole set of results rows and return a single value. And like normal expressions, giving your aggregate functions an alias ensures that the result will be easy to read and process. Alright, common aggregate function, count. Common function used to count the number of rows in the group if no column name is specified. Count the number of rows in the group with non-null values. Count the non-null. Okay. Count that have things in it. Minimum. Find the smallest numerical value, find the largest, find the average, find the sum. Alright. So this depends on each of the. I think this is the software. Like MySQL, Postgres, SQLite, MSS. Group aggregate functions. In addition to aggregating across all the rows, you can instead apply the aggregate function to individual groups of data within that group. What does that mean? Box office sale for comedies versus action movies. This would then create as many results as there are unique groups, defined as by the group by clause, group by column, aggregate function. Instead, apply the aggregate function to individual group of data within that group. Works by grouping rows that have the same value in the columns specified. Group by. Okay, why don't we try? Maybe we will understand it better. We are going to work with our employees. Just one, we are not joining anything. How the rows in this table have shared data. Yeah, like this. We have shared data like this, like 1E, or engineer. Wait a minute. Engineer is all in 1E. Manager is not all in 1E. there are manager into W, because it's a manager for the engineers and manager for the artists. Okay. Notice how the rows in this table have shared data, which will give us an opportunity to use aggregate functions to summarize some high-level metrics about the teams. Find the longest time that an employee has been at the studio. What? Find the longest time. That's max, right? Max years employed. Years employed. We are looking for the number of years, not the wait, how do we max, select max of this. Oh, that's quick. Maybe we need to add as longest, things like that, right? Then it also changes the title of the column. Longest time. Yeah, wow. Alright. For each role, find the average number of years employed by employees in that role. For each role, so it's what average for each role. How do we do for each role? I think we need to group by. Before that, let's look at the data again, like at the table. Role. Okay, so we need to group by role. By role. Wait, why does that happen? wait, why does 3? The group by class works by grouping rows that have the same value in the column specified. Grouping rows that have the same value. I don't really understand this. In addition to aggregating across all the rows, you can instead apply the aggregate function to individual groups of data within that group. As many results as there are unique groups, defined as by the group by class. Select the average of what? Years employed for each. Find the average number of years employed by employees in that role. Why are we not succeeding? Why are we not passing the requirement? What is wrong here? Not sure what is wrong here. Group by role. Is this wrong? Four, 2, 6, 4, 1. 4, 2, 6, 4, 1. 4, 2, 6, 4, 1. Okay, what is the average? 6, 12, 16, 17 divided by 5. 17 divided by 5, bro. There's a decimal point. I don't know, maybe 3.4 things. I guess 3.4, I guess. Okay, how do we do this? Okay, average years employed 5. If we group by role, we got for each role. Okay, maybe we need to also role. Yeah, that's all. Find the total number of employee years worked in each building. Okay, so sum. Is there a sum? Yeah, there is sum. In each building, group by building, group by group by building. Settle. Should be building first, right? Should be building first, then sum. Yeah. Okay, that is new things. That is a new thing. Our queries are getting fairly complex, but we have nearly introduced all the important part of a select query. One thing that you might have noticed is that if the group by clause is executed after the where, which filters the row which are to be, okay, then how exactly do we filter the group rows? Okay, yeah, how? SQL allows us to do this by adding an additional having. What is this? Which is used specifically with the group by. Allow us filter group rows from the results set. Oh, group by this having a group condition. The having clause constraints are written the same way as the where clause constraint and are applied to the group rows. With our example, this might not seem like a particularly useful construct, but if you imagine data with millions of rows with different properties, being able to apply additional constraints is often necessary to quickly make sense of the data. If you are using the group by clause, a simple where clause will suffice. Yeah, I think that is right. For this exercise, you are going to dive deeper into employee data. Think about the different clauses you want to apply for each task. Find the number of artists in the studio without a having clause. Okay, find the number of artists. Find the number of artists. Count. Count. Count what? Count where role equals to artist. This is count role 0. Why is it 0? Select all where row equals to artists. There is no such column as artists. I see. Same mistakes. There is no artists. Yeah. Then we count. Count what? Count it. Just count it. Yeah, just count it. Find the number of employees of each role in the studio. Number of employees of each role in the studio. Group by. We need to use group by. Count. Group by role. Find the number of employees of each role. Count. Role. Yeah, that's not proper. It's not proper. It should be like this. Find the total number of years employed by all engineers. Okay, sum years employed. If I'm not mistaken, years employed for the engineers only. Group by. Instead of group by, we can use where, right? Or group by role. Having, yeah, we need to apply what we learned. Having role equals Genius. Yeah, nice. Lesson 12. At lesson 12 already. Now that we have an idea of all the parts of a query, we can now talk about how they all fit together in the context of a complete query. Okay, each query begins with finding the data that we need in a database, and then filtering the data down into something that can be processed and understood as quickly as possible. Because each part of the query is executed sequentially, it's important to understand the order of execution so that you know what results are accessible where. Okay, order of execution. Okay, which execution happens first? Which things happen first? Oh yeah, like, can we put order by up there, where, down there, or things like that? From and join. From and join. Okay. The from clause and subsequent join are first executed to determine the total working set of data that is being queried. This includes subqueries in this clause can cause temporary tables to be created under the hood containing all the columns and rows. Okay. Firstly, it's from and join. Then it's where. Once we have the total working, where is the condition to the individual rows? Okay. Then discarded. Each of the constraints can only access columns directly from the tables requested in the from clause. Aliases in the select part are not accessible in most databases, since they may include expressions dependent on parts of the query that are not yet executed. Oh, okay. So, aliases better after where, I guess. Group by the remaining rows, and then group based on common values by the group by clause. Okay. Where first. So, both of these are conditional, right? Conditional keywords. Where first, then group by, and then having. Then the constraint having clause are applied. Okay, select. Any expression in the select part of the query are finally completed. Okay, then we select what column we want. This thing, again, this thing is also a conditional because it filters out a lot of things. Order by is just sorting, right? The rows are then sorted. Yeah. Since all the expressions in the select part of the query has been computed, you can reference aliases. Yeah. So aliases, like the variable, can only be used after the select. Usually, the aliases is at select. Can we alias at group by or this? I guess we can. I think we can. Not sure. Order by. Okay. Limit and offset. This is the final. Okay. Conclusion. Not every query needs to have all the parts we listed above. Okay. Here ends our lesson on select queries. What? This is the last. Or maybe this is the first part. Next, we are going to the next inserting about rows and tables. You try and test your understanding correctly because if you find it challenging, just try your best. Okay. Find the number of movies. Okay, wait. What is the tables available? Movies and box office. Okay. Find the number of movies each director has directed. Okay. Number of movies each director has directed. I think we just group by directors. Okay. No, we cannot group by directors because then we'll discard, right? We need to count. We need to count by director. Okay, I am confused right now. I think, okay, how do we tackle this? Okay, like count how many journless letter. I think group by is fine. Group by. I think group by is fine. So maybe group by director, but we count of course we need to have the director to, yeah. Let's go. Find the total domestic and international sales can be attributed to each director. Okay, so we don't need to count, we need to sum. But before that, we need to join. Join the box office on ID equals movie ID. ID equals movie underscore ID. Okay, the sum of domestic and international sales. Why don't we total, okay, wait, total sales domestic sales plus international sales as total sales, sum of total sales. Okay, no such column as total sales, but I save it as total sales though. This is an alias, isn't it? It's an alias, isn't it? Yeah, why aren't we? Okay. Find the total domestic and international. Oh, maybe we separate both of them. Maybe we need to separate both of them. Is that how it is work? Like sum of this guy and then sum of this guy. Is that it? It's not. And then we just add. Then we just add. Maybe we just put a plus here. Is that possible? Incomplete SQL query. Yeah. Okay, wait a minute. How do we do this? Okay, how do we do this? This is actually quite challenging. Okay, wait. This is fine. Just put it as some domestic. Why is it not working? Can we as sum total sales? No, you cannot do that. Okay. This one? You cannot do that either. Okay, this is weird. Why is this an incomplete query? Okay, wait. Okay, this. Just specify in the join. It's grouped by character, so there won't be any duplicating characters. And then we want to add up the domestic sales for each group by director. Okay, wait. Group by when you have aggregate functions. I do have aggregate functions, which is sum of domestic and international. Sum of domestic sales. Director and the sum of domestic sales. Director and the sum of international sales. But find the total domestic and international sales. As some domestic. Yeah, it's working. And then sum of international sales as some international. Then we create another, like some domestic plus some international as word as a word as total sales. Oh, suddenly, we cannot take this. That is the weird thing. Why can't we take that? No such column as some domestic. But this, why we cannot reference this? It's just a name. Unfortunately. Aliases. How do I take that aliases? My table.column. Okay, why don't we look at the previous aggregate result alias? Can we reference the alias? Can we reference the alias? MyWidgets.id, widget sales.widget.id, inner join with widget sales. This better column name, can we use this as the better column? I'm not sure, but we need to settle it somehow. So, oh wait, do we need to redo it? Oh no. Find the number of movies that is directed. Find the number of movies. Count group by directors. Find the total domestic international sales. So instead of count, we use sum of international sales. Oh, we don't join that. Inner join with box office. Sum of domestic sales. Okay, this is not right yet. So can we add both of these? Yes, we can. Yes, we can. But it's not correct. Why is it not correct? I don't know, man. Find the total domestic international sales that can be attributed to each director. Why is it not correct? Why? Oh, I see. It has the same numbers. Why does it have the same numbers? Of course, then it's gonna be wrong. This is not correct, right? This is not correct. When we join them, it becomes incorrect. Oh, yeah, I forgot to inner join on. ID equals what? Movie ID. Okay, this is correct. Okay, so let's try it again. Maybe this time it will be correct. Domestic sales. less sum of additional sales. Yeah, thank you. So that's all for today. Thank you. I hope you will continue to watch the video.